Hello everyone, myself Rucha Anil Shinde, Assistant Professor at Nanashri Institute of Engineering and Technology, Satara. This presentation is created during week 3 and 4 of International FDP on Environment and Sustainability, which is specific to sustainability awareness and sustainability standards. Subject for this presentation is Design and Analysis of Algorithm. So these are the previous two video details. These are the two YouTube links for my videos. For first video, number of views were 18 and number of likes were 4. It is based on the green computing, energy efficient programming languages, and some efficient algorithms and data structures, and also even energy efficient libraries and wrappers. Then my second video got 14 views and 20 likes. The contents were software development lifecycle for energy efficiency techniques and tools. So now these are the some outcomes. First one is understand impact of IT on environment, analyze different strategies to implement green IT concept, apply standards to reduce emission of CO2 in the environment, create techniques and tools for energy efficient software development. So these are some ISO and IEEE standards based on the software development. First one is IEEE 12207. It is standard for information technology software lifecycle process. Second one is IEEE 1074 1995. It is a standard for developing software lifecycle processes. And the third one is IEEE 1490 2011. It is a standard guide to the project management body of knowledge. Now let's see carbon footprint calculation for software development. Carbon emissions are normally measured as a carbon footprint. CF defines how much carbon dioxide a product or service produces. Software has a life cycle, so it also has a carbon footprint. We can estimate and measure it, analyze its sources, and find ways to reduce it. Software has indirect resource requirements. Its development, delivery, and maintenance create a carbon footprint. It uses CPU cycles that create a carbon footprint. It may request services from peripherals that create CF again. All this can be calculated during the software life cycle. The life cycle of software can be divided into the following phases. First one is the development, in which the software is implemented. Second one is the beta testing. It is nothing but the potential customers taste the software. Then is the delivery and redelivery. This is based on the software delivered to the customers. Next is the usage. It means the software is actually getting used. Then last one is the maintenance. It means we have to look after the maintenance of software, like keep on updating the softwares likewise. Since the life cycle consists of the previous phases and each phase has a carbon footprint, it is safe to define that carbon footprint of a software is the sum of the carbon footprints of the phases. So this gives us the following definition. So here I have mentioned a formula that how we can calculate the carbon footprint for this whole software development phase. So here it denotes NS is nothing but the number of delivered software packages. DS is nothing but the carbon footprint generated at the time of development. BS denotes the carbon footprint generated at the beta testing. Then RDS denotes CF at the time of delivery and redelivery. MS denotes the CF of maintenance, and US denotes the CF of usage. So now let's assume the example of compiler software. So the estimated values are, suppose we are considering the development phase. So for the development around 5100 kg CO2 emission happens per 10 K of code. It means 10 K line of code. Then is the for beta testing. For beta testing, around 7,300 kg CO2 emission happens per 100 tester. Then is the delivery. At the delivery phase, around 2,600 kg CO2 emission happens for 10,000 copies. And then usage, for usage, around 160 kg CO2 emission happens per installed copy. So now let's see how the sustainability computation happens for software development. The existing model for green software engineering, it does not consider the requirement, design, coding, testing and implementation phases of software development lifecycle. So in order to achieve green software engineering in the entire software development process is to become a green. So we can define sustainability as the ability to be overseen at a steady level without depleting environmental assets. So the purpose of green and sustainable software engineering is to improvement of software engineering during the entire life cycle of software system, which targets direct and indirect consumption of natural resources and energy, and the aim is to track, assess everlasting measures and optimize these realities. This is what a green soft model, that's nothing but green and sustainable software model. The green soft representation, it's a conceptual reference model for green and sustainable software. The aim behind this is to support software developers, administrators and software users in creating, maintaining and using software in a more sustainable way. This method comprises a holistic life cycle model for software products, procedure models for different stakeholders, and recommendations for actions that support stakeholders in developing, purchasing, supplying, and using software in a green and sustainable manner. The reference model contains a life cycle of software product that is in contrast to conventional life cycle software generated to life cycle thinking related to development, usage and end of life, and identify the first order effect, second order effect and third order effect. The second part of the green soft model is called sustainability criteria and matrices. It covers common matrices and criteria for the measurement of software quality, and it allows taxonomy of parameters for evaluating the sustainability of software products. Hence, lack of sustainability is a major flaw in the existing green software model in the following phases, such as requirement, design, coding, testing and implementation. There are a lot of negative impacts such as high level energy usage, e-hazardous waste, ecological system, financial, etc. So the researchers proposed a new green-based software development life cycle in designing, implementing and evaluating phases for a sustainable development to overcome the above factors. So thank you. These are the references.